Showtime!
Ladies and gentlemen, please make your way to your seats.
Showtime!
Please make your way to your seats. The show is about to begin.
Showtime!
Let the magic begin.
Tauonium to replace hydrogen.
Yeah, so this one is, we're talking Futuretech, we're talking really complex stuff, and I'm going to break this out. And I don't even know. So typically when I'm learning something new, I'll type in how to pronounce, and they don't even have a how to pronounce this. So I'm guessing it's Tauonium. But I'm going to break this out into three kind of topics. So I'm going to introduce Tauonium first. Tauonium is a hypothetical atom composed of a tau lepton and its antimatter counterpart. It could be the smallest and heaviest known pure electromagnetic atom. So its existence was first theorized decades ago, but tauonium has never ever been detected. It has a radius of 1/1700th of a hydrogen atom. So the tauonium atoms interact solely through electromagnetic forces between the oppositely charged tau and anti-tau. This is simpler than atoms like hydrogen. So they've proposed a new detection method. So in recent theoretical works, they've suggested a novel technique to identify tauonium using particle accelerators. So by colliding electrons and positrons at high energies near the tau particle creation threshold, the subsequent particle decays can reveal a unique tauonium signature. What they've calculated is that this proposed approach could provide the first experimental evidence of tauonium at a 5 sigma certainty within a few years. So interesting. Now, what are these implications? So detecting tauonium would enable testing quantum electrodynamics theories at unprecedented smaller scales. Again, we're talking your magic, right? It would also allow ultra precise measurement of the tau lepton mass at 1 keV of accuracy, which is 100 times better than current experiments. This would have major impacts on particle physics and standard model, including electroweak theory and questions around lepton universality. So essentially, what they're saying is that finding tauonium provides a new portal into quantum foundations of matter, forces, and mass. And again, still theoretical. They have a detection method proposed. Still hasn't been detected. So yeah, there's some interesting stuff here. But again, never seen, never measured, never nothing.
Yeah, it said 5 sigma certainty, so that's 99.999. Or
Yeah,
is
I think
it
so.
99999?
99. I think it's
Anyway,
5. Yeah, I think it's 5 nines, but I could be wrong.
Yeah, that's I just can't remember. It's 5 nines after the decimal or 5 nines total.
Yeah. I can't remember.
Anyway, I guess my point being is they're fairly certain that the significance of observing time will exceed. So they're fairly certain this exists, but they haven't figured out a way to detect it yet. So let's start at a different level. How exactly does tauonium differ from normal atoms like hydrogen, and what makes it simpler?
So yeah, it's in a few key ways. So it contains a tau particle and an anti-tau particle rather than an electron and a proton like in hydrogen. So the tau and anti-tau, they have no substructure. So they behave like fundamental point particles. So in contrast, the proton in hydrogen is made up of, you're going to love this, quarks and gluons. And so tauonium only involves 2 truly structureless particles interacting. And so the binding force is purely electromagnetic between the charges of tau and anti-tau, or tau plus and tau negative. There's no nuclear force involvement, as in hydrogen, between the proton and electron. So with just the electromagnetic interactions, tauonium is considered a simpler atom. And theoretical models treat the particles as perfect point charges with mass. So this is kind of the easiest system for analyzing the effects of quantum electrodynamics. So just to kind of summarize all that gobbledygook, the lack of a complex structure and pure electromagnetic binding makes tauonium a simpler theoretical construct than even the simple hydrogen atom. And studying it can reveal deep insights into quantum mechanics unobscured by complex nuclear or structural effects, if that makes sense. I think I explained it a little bit more better there.
Okay, so let's just say tomorrow we discover this tauonium. What kinds of new technologies, does it actually replace hydrogen at anything?
So there's a couple of things. So encryption. Quantum cryptographic protocols could use tau particles to generate secure keys, which I find is pretty cool. There's medical applications. So tauonium's radioactivity could possibly be used to target tumors or provide unique radiopharmaceuticals. Miniature electronics, so devices like quantum computers may leverage tau particles or tauonium for compact circuitry and qubits. So this is the potential breakthrough that we could talk about that we were talking about. So ultra precise clocks. So again, we're always trying to get to super precise atomic clocks. So the high mass of tau particles means that the tauonium electron transition between energy levels at high frequencies, and we're talking petahertz range, could allow for very precise timekeeping. There's a whole bunch. High energy chemistry, so chemical reactions involving matter and antimatter annihilation at the tauonium scale could unlock new energy pathways, which is really cool. So a lot of some way out there and some things that are actually more practical, which is interesting.
Okay, so will this discovery open up new realms of chemistry or material science? Like, we haven't even discovered it yet. We don't even know how to mine it, get it from, like, it exists, but it exists as a parts of other atoms. Do we have to pull it out? Like, how does this work?
Yeah, so it could open up.
We don't know yet, obviously.
Well, no, but yeah. So the thing is even though like tauonium's been theorized for many, many years, right? So there's obviously been some research done into it and different things like that. So there are exciting new directions in chemistry and material science that could open up. So one is exotic materials. So tauonium's small size may make it useful for designing materials with unique nanoscale structures. So materials containing antimatter could have applications from microelectronics to medicine. There's bioimaging and sensing. So if production can be scaled, tauonium size may make it an ideal nanoscale tag for sensing biomolecules within cells or tissues. There's obviously, we talked about particle chemistry, but tauonium could inspire new particle-based chemistry. Antimatter chemistry could reveal new energy pathways and compounds. High precision spectroscopy. So it could detect subtle quantum effects, allowing measurements of extreme precision. A whole bunch of things. It could open up so many different things, which is really cool because it seems like they're one step closer to being able to detect it. But again, who knows?
Yeah, this is really interesting in a number of ways. Obviously, if it can help us create energy, if it can help us get interesting quantum stuff, do quantum encryption at some levels, maybe even potentially be used in some of the quantum batteries we were talking about, because if we can get to the particle and the antiparticle easily.
Exactly. Yeah.
You have any last words on this tauonium?
No. So just one thing, just to note that tauonium is theoretically highly unstable and it decays in trillionth of a second, which makes directly observing it extremely difficult. So just to put that into perspective, just wanted to add that, but that's pretty much it. Yeah. Like we can't even guesstimate any timelines for this one. So
what do you got going on, John?
nothing. I got this thing today. And then
Startup Drinks TO tonight.
Investor Startup Drinks TO. I love it because with your ticket you get food, you get drinks, and you can pitch. You can pitch yourself, you can pitch your idea, you can pitch your company, whatever. There's investors, there's people from all walks of life that come. It's a great event. I love it. That's pretty much all I have coming up in the next little bit, which is great because I've been traveling to Toronto quite a bit recently. How about you?
Well, tonight, like you said, Startup Drinks TO. We got more fans in the room. We got a new portable AC unit. I'm hoping our step and repeat banners there. We have a chicken wing sponsor tonight, so we're gonna have chicken wings. So we got a lot of new stuff. And then June 20th is our collision after party. I want to make sure people come join that. And if you want to learn how to take your knowledge,
get your tickets early for that because we were sold out last year. So
yeah, we will be sold out again. We're already at over 100 gone for the collision after party, and we're still over 3 weeks away.
Yeah.
So we will sell out again. So get your tickets early. Make sure it'll be a great time. It's our biggest one of the year.
Yeah.
If you're a subject matter expert and want to figure out how to turn your knowledge into a course, book, or coaching program, go to startupcoach.ca, book a discovery call. I'll show you how I can help experts like you take the knowledge out of their head and turn it into a high ticket course, and you can start earning money. So give me a shout and we'll do that. I've got a few clients already lined up and it's working out really great. So it'd be nice to have a few more. And John, you help companies get funding. So if people are, doing business stuff and they're looking for funding, usually it's companies doing tech work with developers or doing new stuff. What do they need to do?
There's tons of funding if you're developing a new food product, beverage, if you're in tech, if you're in agriculture, if you're in med tech, if you're looking to hire, there's something out there for everyone. If you're developing new tech, there's some great stuff like Shred. But yeah, reach out to me on LinkedIn, John Irwin, JONIRWIN.
And for everything else, just go to TorontoStarts.com. Everything's there. And thanks everyone for watching. We will be uploading separate videos of that. I know the audio wasn't great. Hopefully we'll be getting separate audio. That'll work out better when we upload it. Thanks again, John, and I'll see you tonight.
Wow, that was amazing.
And it's all just like that.
See you later, alligator.